Hello students, in this session we will discuss about the way of inserting a node into the single linked list. So when we observe the process of inserting a node, it falls into three cases like front insertion, rear insertion and any position insertion. Here case 1, front insertion. In this case, a new node is inserted at the front position of the single linked list. For this, now observe this algorithm of insertion of X. So this procedure is used to insert a new element X at the front position of the list. For this, step 1, allocate memory for a new node. Data of new is filled with X, link of new is filled with null pointer. Now step 2, first we check whether elements are available or not. So if start equivalent to null, then that means elements are not available, hence start and end are set at new node. Otherwise, else. Now we establish links in between new and start node as link of new equivalent to start, start equivalent to new, and if. Now we return from the function. Here observe this example. So this one, initial status of the single linked list. Here we are applying front insertion operation. Hence, a new node is inserted at the front position of the list. So after performing these operations, now the list becomes 26, 59, 38 and 64. Now case 2, rear insertion. So in this case, a new node is inserted at rear position of the single linked list. Algorithm or insertion of X. This procedure inserts a new element X at rear position of the list. This process, step 1, allocate memory for a new node. Data of new equivalent to X, link of new equivalent to null. Step 2, if end equivalent to null, then start equivalent to end equivalent to new. Otherwise, now we establish links in between end node and new node as link of end equivalent to new and equivalent to new, and if. Now return from the function. Case 3. So for this, first observe this example. So this one, initial status of the list. Here it has 3 elements, 59, 38, 64. Now we apply our insertion of 26. So after performing this operation, now the list becomes 59, 38, 64 and 26. Now case 3, any position insertion. So in this case, a new node is inserted at the specified position of the single linked list. Here is algorithm any insertion of X comma POS. This procedure inserts a new element X at the specified position POS of the list. Procedure, step 1, allocate memory for a new node. Data of new equivalent to X, link of new equivalent to null. Now step 2, now K equivalent to 1, PTR equivalent to start. Now step 3 is a repetition process. Repeat while K less than POS, temp equivalent to PTR, PTR equivalent to link of PTR, K equivalent to k plus 1 and repeat. So when we apply this process, now the control moves to specific location by pointing to pointer variables. Now we establish links as link of temp equivalent to new, link of new equivalent to ptr. Now return from the function. Now observe this example. So assume this one initial status of the list. Here the elements are 59, 38, 64 and 26. Now we apply any insertion of 14, 3. That means we are interested to insert a new element at the third position of the list. Hence, after performing this operation, now the list becomes 59, 38, 14, 64 and 26. So this one insertion operation. Now we go for the way of deleting a node from the list. Now as similar to insertion process, a node can be deleted from the single linked list with three possible cases like front deletion, rear deletion and any position deletion. First case, front deletion. So in this case, the front node information is deleted from the single linked list. This algorithm F deletion. Now observe the procedure. If start equivalent to null, that means elements are not available. Hence, we return a value as return minus 1. Else, that means elements are available. So first access the data part of starting node like k equivalent to data of start. Now we check whether the list consists only one element or more than one element. So if start equivalent to end, that means list consists only one element. Then set start and end both pointer variables at null pointer. Otherwise, else. Now temp equivalent to start. Now start equivalent to link of start. Link of temp equivalent to null. Now we break the link in between temporary node and start node. Thus, we release memory of temp and if. Now return k, which is the deleted element, and if. Let us example. This one initial status of the list. Here, the list has 4 elements, 59, 38, 64 and 26. Now we are applying F deletion operation. So the front deleted element is 59. So after performing this operation, now the list of elements are 38, 64 and 26. Now case 2, rear deletion. In this case, rear node information is deleted from the single linked list. Now algorithm process. Step 1, if end equivalent to null, then return minus 1. Else, now first access the data part of end node. So k equivalent to data of end. If start equivalent to end, then start equivalent to end equivalent to null. Otherwise, else. Now ptr equivalent to start, temp equivalent to end. Now repeat while link of ptr not equivalent to end, ptr equivalent to link of ptr and repeat. Now shift end to pointer variable ptr. So end equivalent to ptr. Now link of end equivalent to null. Now release memory of temp and if. Now return k and if. Now observe this example. This one initial status of the list. Here the elements are 59, 38, 64 and 26. Now we are applying OR deletion operation. Hence rear deleted element is 26. So after deletion of this element, now the list becomes 59, 38 and 64. Now case 3, any position deletion. So in this case, a specified position element is deleted from the single linked list. Now algorithm process. Step 1, if start equivalent to null, then return -1. Else ptr equivalent to start, p equivalent to 1. Now repeat while p less than pos. Now temp equivalent to ptr. Now ptr shifted to link of ptr. Now p equivalent to p plus 1 and repeat. So with this repetition process, first control moves to specified position element. Now k equivalent to data of ptr, which is necessary to delete the ptr element. So link of temp equivalent to link of ptr. Link of ptr is filled with null pointer. Now release memory of ptr. Return k and if. Here observe this example. So this one initial status of the single linked list. Here the elements are 59, 38, 14, 64 and 26. Now we are applying any deletion of 3. That means we are interested to delete third element from the list. Hence deleted element equivalent to 14. So after deletion, now the list of elements are 59, 38, 64 and 26. So these are 3 possible cases. So in such a way, it is possible to implement insertion and deletion operations. Now finally, when we go for disadvantages of a single linked list, when we observe the diagrammatic representation, in single linked list, it is possible to traverse only in one direction. Here, only forward direction traversing is possible. Backward traversing is not possible. To overcome this disadvantage, we go for another type of linked list known as double linked list. Thank you one and all.